Okay, this is a velocity time graph. This is one of the newer graphs. We don't really use these, or haven't used them a lot in the past, so this will probably explain a lot about them, but they are quite straightforward. It's just about understanding some of the features. So Shelley puts on the rollerblades and accelerates constantly to a velocity of 4 meters per second in 20 seconds. So she's gradually getting faster and faster until she gets to 4 meters per second, and it takes her 20 seconds to do that. She then stops accelerating, so she stops trying to speed up and stays at the same speed, the constant velocity, for a further 40 seconds. And then she starts to brake, starts to slow herself down until she comes to a rest. So she's stopped, and it takes her 10 seconds to do that. And we have to record that journey on this area here. This has been quite nice to you because it's giving you where the axis should go. But time would always go on the bottom anyway. Okay, so time, we've got to decide how much time we need to sort of include, or how long it's going to take. So she takes 20 seconds for the first bit, 40 seconds for the middle bit, and 10 seconds for the last bit. So that's 70 seconds that we have to graph. Okay, and this has got loads of space for it. So I'm going to do my dashes. I'm going to go in tens. What I mean by dashes is the little markers to see if I can do it. So 0, 10, 20, 30, 40, 50, 60, 70. So it does fit. Okay, so it definitely fits. So do those first. And then you know you're not going to make any silly mistakes. So 0, 10, 20, 30, 40, 50, 60, 70. Okay. The velocity, if you just have a look at the information, she goes up to 4 meters per second. So velocity is another sort of idea of speed, 4 meters per second. She stays at that speed in the middle line, and then she goes down. She comes down from 4. So the fastest she's going to be traveling is 4 meters per second. So I'm going to use these big blocks as ones. I've got on there like that. Okay, so that's the axis sorted. So that'll be 1 mark, I imagine. The next bit is to plot the information. So it's traveling, accelerating up to 4 meters per second. So starting from 0, accelerating up to 4, which is up here, and it takes her 20 seconds. So she's going up to 4 in 20 seconds. So you can see I've got it in line there. But because it's a constant acceleration, it's a straight line. Okay, so she's not getting any. She's not doing speed up a little bit, then going really fast in terms of trying to speed up. She's just doing the same sort of push and acceleration on rollerblades. Then she's going to stay at a constant velocity. So the velocity is going to stay at 4 for 40 seconds. So that takes up to 60, which is there. And then she's going to de-accelerate. She's going to come back down at a constant rate, back down. And the word constant just means that we're going to have straight lines. So that's the graph from there. Okay, so it's more straightforward than you might imagine. We need to calculate the distance she's travelled. With velocity time graphs, if you think about distance is speed times time. So it's the actual area under the graph that we're going to do. So we're going to do the area of this graph. So to do the area of this graph, under the graph, sorry, we've got this little triangle here that I'm going to work out. And that is base times height divided by 2. So that's going to be 20 times by 4. Well, how to do that? 20 times by 4, which is 80. And I'm going to divide that by 2. So 80 over 2, which is 40. God, why did I do that? So anyway, first triangle is 40. So base times height divided by 2. I'll do a better example here for this one. So this is another triangle here. So we'll do that there. There we are. So base is 10 and the height is 4. So 10 times 4 divided by 2. So that's 40 divided by 2. So this area is 20. You can see I'm adding this together because it's the total distance. And I've got this rectangle, which is just length times length. So this is from 20 to 60. So it's 40 wide and 4 high. So that'll be 4 times 40. 4 times 4 is 16 with an extra 0. So add 160. Okay, so the easiest way to do it is add those two to make 200, then add that to make 220. Okay, So that's what I've put there, 220 meters. So because it's velocity times time, speed times time, that's how you get your distance, and that's the same as calculating the area under the curve or under the graph. Okay, here we are. Right then, question 22. Question 22 is a standard histogram from what I can see. There's no extra questions. It's just setting you up to draw a standard histogram. So if you can do histograms, this is a nice, easy one. Okay, but it all starts with this axis here, the frequency density. So I'm going to label that up. So frequency, I'll put it back on the camera, frequency density. Okay, so that is this axis, and I don't have it. So my first job is to actually work out the values for that. So this is going to be my frequency density. Okay, and the frequency density is the frequency divided by the width of each class interval. So if I figure out the gap between these numbers, this is how wide each group is going to be. This is the width of the group. And then the way I like to think of it is the frequency is first in frequency density. So the frequency goes first, and then we're going to divide. So we're dividing the frequency by the class width. So you just can't be able to divide, so that's going to be 4, that's going to be 12. 200 divided by 2 is 100, so divided by 10 is 10. Okay, and 8 divided by 5 is 16. So those are my frequency densities, and those need to be used on this scale. The maximum one is 16, so it's got to go up to 16. So you've got to try and choose some convenient scales to go up to. So I've got 1, 2, 3, 4, 5 big squares. I could do anything I want really. I'm trying to think of a convenient one. I'm going to go up in 4s. Might be a mistake. To get on there. The thing you're trying to do is make sure the scale's easy to use. So when I say it might be a mistake, these little bits here might be inconvenient for me to use with this being a 4. It'd be better if these were going up in like 1s. But there you go. So to draw a histogram, it's nice and straightforward. It tells you where the bar starts and where the bar ends. So the first one is going to be from here to here, and it's going to go up to 16, so that's the height of your bar. So this is not going to draw very well because of the colour of the paper again. So that's going to go up to here. I'm just going to shade it so you can see it better. You don't have to shade it in the exam ever. Okay, so that's what we've got so far. And then all you do is you keep using your widths, your labels to figure out where you're going to go. So the next one's from 5 to 10, and that's going to go up to 4. So that's there. Again, it's shocking because of the way the paper is. So that's this one. And then 10 to 20 up to 12, 10 to 20 up to 12. Now, the scale's not worked out too bad really because it's not using like 13s or anything like that. They're all nice even numbers for me to use. So that's that. And then, what else have I got? Oh, that was 10 to 20. Whoa. This is where you're going to get annoyed, but at least you'll learn from my mistake. It was 10 to 20, so that's how wide that bar should have been. They're not all the same, so it should have been that wide. Okay, so it should have been that wide. The next one's 20 to 40, which is a lot wider, and it goes up to 10. So 10 is halfway between 8 and 12, so I'm going to go there. Okay, so that's a much bigger one. Like that. So you can see that there. That's that part. So that is a typical histogram, where you work out the frequency density first, and then show the examiner you understand how to plot the different values, different bars. Sometimes you will have missing information, so this table may not be complete, so they might miss that one out, and then you have to find that, fill the table in from the graph. And this is kind of how I see this. This is how I summarize histograms. You divide to draw. So you could see I had to divide here to find out how high my bars were going to be. And then if you want to read it, if you actually want to read the graph, so if I want to know what was in that group, how do you know it's 200? You times to read, you multiply to read. So for example, let's say I didn't know that was 200 and I said, what is the frequency of this group? How many people in this group here? I knew that it's just a simple rectangle, it's 20 wide and it goes up to 10. So I could multiply it back out, and that's how you read a histogram. Okay, and the questions that they go on to is about, let's say, what proportion are 30 pounds and higher. I could figure out the area of this bit and write that as a fraction of everything. Okay, so